Hello my friends, I'm Mohamed Amin Ganjabi from Sharif University of Technology. This video is about simplified approach. Our simplified approach are used to decrease the simulation time. But be aware that this also decreases the result accuracy. For different process type, Simufact.welding offer different type or approach to reduce the simulation time, like neglection of welding sequence, decoupling of model, or linear material models. Table of content. Introduction. Shrinkage method for thermal joining, arc laser beam welding and brazing. Single shot solution for thermal joining, arc laser electron beam welding and brazing. Single shot solution resistance spot welding, mechanical solution only. For arc welding, laser beam welding, electron beam welding and brazing, the following approach can be used. Shrinkage method, linear material model, only shrinkage of weld seam is simulate. Single shot solution for thermal cycle, neglection of welding sequence. For resistance spot welding, the following approach can be used. Single shot solution, neglection of welding sequence, mechanical solution only, decoupling as no electrical or thermal simulation will be performed. Thermal cycle, decoupling as no electrical simulation will be performed, can be used in combination with single shot solution to neglect the welding sequence. Shrinkage method for thermal joining, arc, laser beam welding and brazing. The shrinkage method is applied for very large structure as common in shipbuilding and aerospace industries. This method gives a brief idea about direction and order of magnitude of destruction of the complete assembly as a result of shrinkage of weld seams due to cooling from melting temperature to room temperature. As soon as the model including seams is prepared, the shrinkage method can be activated in the solver dialog by using the checkbox Simplified approach and activation the radio bottom shrinkage heat source for this approach for acting on fillets. This means all trajectory assigned to robots needs fillets assigned to them. After the activation, the model is changed and simplified in following way. All heat input happen at once. All weld lines are experience the same heating period where the temperature rise from room temperature to melting temperature of fillet material during the time period of the welding duration of the longest weld line. Afterward, the temperature stays constant until the end of the process. Boundary conditions that are deactivated during the process are deactivated at once shortly after the heating period ends. Boundary conditions without deactivation time are active until the end of the process. Material data is linear to temperature dependent size expect for thermal expansion coefficient. The material is modeled to behave in the ideal elastoplastic way does not work. Hardening appears. The thermal expansion coefficient change its sign. Thus the heating leads to shrinkage of material. This is equivalent to apply negative temperature change to the structure. Only fillets are experiencing the heat input. There is no heat transfer between fillet and components. Thus, a steady state situation is achieved after heating and unclamping is complete. Single shot solution for thermal joining, arc, laser, electron beam welding, and brazing. The single shot method is also applicable to large structure, delivering in case similar to cases that are well suited for shrinkage approach. Better approximation of expected assembly behavior needing for calculation time. The approach is activated on a complete model by checking simplified approach and activation single shot solution. For well suite model, this approach delivers a fast approximation of distribution, stress, and material state. The material data is not changed, but the welding sequence is ignored. On the other hand, the stability of single shot solution usually gives a hint if the model is well set. Poor model setup like bad mesh penetrations will be visible very quickly with this approach, while the calculation with respect to welding sequence might take days until the problem region will get visible in the model. Depending on the model size, the speed up is very significant, getting higher if the number of weld lines is growing. Single shot solution. The single shot solution for resistance spot welding process neglect the effect of the welding sequence. That means that all spot welds of the complete model are welded at the same time. The model is adjusted in terms on pause time. The activation of the single shot solution can be done by simply activating the checkbox in the solver dialog. The process has not to be changed or anything else. When the single shot is active and the simulation is started, Simufact.welding will automatically pair for every spot weld is present. The result accuracy differs slightly in the below shown compression, but this can change in other model. So please be careful when post-processing the result and be aware of decreasing result accuracy when using simplified approach. Mechanical solution only. The mechanical solution for resistance spot welding process neglect the coupling effect, as only the mechanical simulation will be performed. No electrical or thermal simulation. This type of simplified approach can be used if the resistance spot welding process is only of secondary importance. If the stiffness of the joint is only important to analyze the clamping concept or to use the result future process. The activation of mechanical solution can be done by simply switching the radio button in the solve dialog. The mechanical solution is not compatible with the single shot solution and support only one robot. Therefore, adjustments on the process might be needed to perform the mechanical solution. Thank you for watching the video. Good luck.